Today what we're going to do is look at factoring trinomials, and we're going to take it in two parts. The big difference when we're factoring trinomials is looking at the leading coefficient, whether it's 1 or anything other than 1. Now, a couple things to note. First, remember that our first step whenever we factor is we want to look for a GCF. And that's true whenever we're factoring with any method. Now keep in mind, as far as factoring goes, the method that we use is usually going to be based on the number of terms in the polynomial. We always check for a GCF regardless of the number of terms. Whenever we have 4 terms or more, we're often using factoring by grouping if the polynomial is further factorable. When we're using 3 terms and we have trinomials, then we're going to be using what I call the product sum method. So we're going to be focusing on products and sums. So to factor our trinomial, when we have it in standard form, x squared plus bx plus c, and our a value equals 1. What we're looking for is a pair of numbers whose product is c and the sum is b. Whenever we factor, once we find those two numbers that give us the desired product and sum, then we're going to have two binomials where it's going to be x plus or minus whatever one of those numbers is, and plus or minus the other number, depending on whether the number is positive or negative, will determine the plus or minus. Any polynomial that cannot be factored with integer coefficients, again, is considered a prime polynomial. Now, as part of this method, we want to be very careful, and I'm going to go through the long formal way of how these polynomials are factored. And then what we'll do is we'll apply the shortcut that we have here. Because the long method is important for understanding because it's what we're going to be using when we have a leading coefficient that's not 1. And so it's important to understand why our shortcut works and what's really going on kind of behind the scenes. And if you don't have your graphing calculator handy, go ahead and grab it because there's an easy way to help us identify our product pairs with our calculator here that can make our work a lot easier, especially when we get large values of c. So let's go through the long way and then we'll look at our shortcut. So the first thing we want to do is we want to identify our product and sum. I want a product of my c value, which is 16, and I want the same numbers that also give me a sum of my b value, which is 10. Now make sure you take the sign with you. Both of these are going to be positive, so we don't have to worry too much, but I want a positive 16 and I want a positive 10. Well, let's think about all the numbers that multiply to give me 16. I could multiply 1 and 16. I could multiply 2 and 8. I could multiply 4 and 4. But I could also multiply negative 1 and negative 16, or negative 2 and negative 8, and negative 4 and negative 4. All of these will multiply to give me a product of positive 16. Well, then I want to go through and I want to look through this list and see which set gives me the correct sum. Well, since I want a sum of positive 10, I'm going to take the two numbers, 2 and 8. Now let's see how our calculator could speed this process up for us. We know we want a product of 16, so we're going to go into our calculator here, and I'm going to go ahead and turn on the key press history so you can see exactly what I'm doing here. I'm pressing y equals, which is up at the top left, and then I'm going to type in my value of c, which in this case is 16. Then divide, and then our x, which is again up here kind of towards the top near the green and blue buttons. And so I want my c value divided by x. Next thing that we do is we're going to go ahead and press second and then graph, which opens up this table. Now, focusing on this table, what we want to do is we want to find the pairs that add up to our b value. And we can scroll through each of these rows and get all of the factor pairs, the same that we had over here on the left where we were finding the factor pairs on our own and adding them up. And we can see we have 1 and 16, we have 2 and 8, we have 4 and 4. We can also go up, and I see I have negative 1 and negative 16, negative 2 and negative 8, negative 4 and negative 4. So we can scroll through this list and we want to find the row that adds up to what we want. And so we can see we have the values 2 and 8 that add to 10. And so that's how we can get our factor pairs a little bit faster. Now, with a very formal way of doing this, what we're going to do with the 2 and the 8 is we're going to take 10x and we're going to split it into 2x plus 8x. 2x plus 8x gives us 10x. And then we're going to write the rest of our trinomial out next to it. So I have the same trinomial, but now it's unsimplified, and I rewrote the middle term into 2 terms. The reason for doing this is now we have 4 terms in our polynomial, and the way we factor 4 terms is by grouping. So we split our groups in half. We find the GCF of the first 2 terms, which is x, the GCF of the last 2 terms, which is a positive 8, and we notice that we have our matching binomial pair. We factor out our matching binomial pair, x plus 2, and that leaves us with just x plus 8. And so now we have our factored trinomial. You'll notice that the 2 and the 8 are the same values we picked up as our product and sum pair. So as long as our leading coefficient is a 1, then the shortcut is that we don't have to do the factor by grouping. The 2 numbers from our product sum pair will be the constants in our binomial factors, matching plus or minus whether or not the numbers are positive or negative. So let's go ahead and try it again with slightly different numbers. So here we got our quadratic in standard form. We want a product of C, which is 35, positive, and we want a sum of B, which is a negative 12. So we're going to go back to our calculator, and I want a product of 35, and I want to look at my factor pairs, and I want to add to negative 12. Well, when I look here, negative 5 and negative 7, those are the numbers that add to negative 12. And so we can go ahead and apply our shortcut. We're going to have 2 binomials, our variable y, and since it's minus 5 and minus 7, those will be the constants in our factors. And we've factored our trinomial. We can go ahead and, if we want, we can double check our answer by multiplying these 2 and making sure that we get our original polynomial. Y squared minus 7y minus 5y plus 35. Combine like terms. And we ended up with the original polynomial that we started with. So we know that our answer is correct. Now when we look at C, we notice that, hey, something's wrong here. We don't have a quadratic, we don't have a degree of 2, and our leading coefficient isn't a 1, it's a 5. Well, don't forget, our first step is always look for a GCF. We often won't have one, but when something looks a little off, we definitely want to make sure that we double check for a GCF. It's a good idea to get in that habit. If your leading coefficient is something other than a 1, or the degree on your polynomial is something that you didn't expect, look for a GCF first. Here our GCF is 5x, because all of these terms can be divided by 5x. So when we factor out 5x, we're left with x squared minus 6x minus 7. Now this is something that we can go ahead and factor. A product of negative 7 and a sum of negative 6. We can look at our factor pairs. And in order to get a negative 6, we need a positive 1 and a negative 7. So we can use our shortcut, x plus 1, x minus 7. Now, something that happens a lot is our GCF often disappears. It needs to be included within our final answer. So don't lose your GCF along the way. For D, again, we have a leading coefficient that's not a 1. So we check for a GCF. In this case, our GCF is the number 2. We have 2n squared minus 19n plus 40. And we want to find a pair of numbers that multiply to give us 40, but add to give us negative 19. Since we're trying to add to a negative number, we have to look in the negative values. Well, we start -1 and -40. Give us 39. Well, that doesn't work. Or -41. Then we've got -2 and -20. That gives us -22. That doesn't work. Next, we've got -4 and -10. Gives us -14. That doesn't work. -5, -8. That gives us -13. That doesn't work. And notice how -19 would have needed to go somewhere in here. And so since there's no two integers that add to -19, I can't factor that any further. So we're done.